All right, guys, we're going to try and keep this significantly shorter than the last video. Power of compounding. So we're talking about interest, and kind of a problem that we're going to keep coming back to. It's just kind of a silly one, but it kind of makes the point that we're trying to make. Clear back in like 1461 or something like that, King Edward borrowed, I think it was the fourth, something, King Edward the fourth, that sounds right, borrowed like $384 from the New College of Oxford. So he borrows this $384 and he only pays back $160. So he's left owing $224, and it completely gets forgotten about. He doesn't ever pay it. No one ever says anything about it. So 535 years later, a new administrator at the college finds this information and realizes, hey, the king owed us this much money back then. If he was going to pay us 4% interest, that would mean that now that $224 has turned into like $290 billion. And he actually sent a letter to the queen saying, hey, you owe us this money. You forgot to pay us back. And of course, it never happened. But the idea that $224 can grow to almost $300 billion in 500 years is insane. But that's the kind of exponential growth you get when you're dealing with compound interest. So we're going to talk about compound interest a lot today. We're also going to briefly discuss simple interest as kind of an example right here, and then we'll go up to the definitions. While banks almost always pay compound interest, bond issuers usually pay simple interest. So what simple interest means is you have $1,000 savings bond, and it pays 10% interest per year. What that means is after 1 year, they're going to give you 10% of $1,000. So after 1 year, that's going to be $100. But a year later, your bond was still $1,000, so they still give you $100 the second year. The third year, you get $100. Every year, because they're using simple interest, which just means based on your initial investment, we'll give you 10% every year for that amount. So after 5 years, which is what this problem asks, after 5 years, they would have given you or owed you $100 per year. So that savings bond would have gotten you $1,500 after 5 years, which is a lot of money. That $1,000 that you paid plus $500. That's simple interest. It's interest, and the definition's right up here. It's only paid on the original investment, not any interest that gets added on. Now, compound interest works a little bit different. What compound interest would have done is taken your $1,000, and after 1 year, it would pay you 10%. So now it would say that you have $1,100. And after a year, it would pay you 10% of your new amount. So it would pay you $110. So you would have $1,210. After another year goes by, they'll pay you 10% of the new balance, not the original $1,000. So they'd pay you another, $121? So now you've got $1,331. So every year they pay you not just the 10% on the original, but they pay you on the interest that you earned each year. That's called compound interest. And it's always going to yield more money. At the end of this 5th year, well, let's see, this was 1 year, 2 year, this is only 3 years. They're going to pay you another 10% and then another 10%. So you're significantly higher than the $1,500 that you started with. Okay. So what, and principal, I've said that a couple of times already. Principal is just the amount that you started with. That's called your principal balance. And in this kind of math, a lot of times we reference it with a capital P. Okay, so if you need to review roots, powers, power rules, functions, pause, look this over, make sure you understand what it's talking about, because some of this is going to come up a little bit in the homework. Okay, moving on. So the compound interest formula, rather than having to, really what you're doing is you're adding the interest at the end of the year. Another year goes by, you find the new amount of interest and add it, and you have to keep repeating that process every year. Luckily, we're pretty good at math and came up with a formula to make this easier for people to do. So the formula that you use is A equals P times quantity 1 plus APR to the Y power. Now, A is the new amount. That's how much you've earned. That's your new balance. P is the principal. That's what you started with. 1 is just represents 100%. That's the amount. APR is your annual percentage rate. That's your percentage rate per year. And the Y is the number of years. Okay, so in the case of the new college, the king borrowing money, the interest rate was 4%. It's paid over 535 years. So if I were to say A equals principal, we said it was what, like $224 or something like that, multiplied by 1 plus the APR, the interest rate, 0.04. Be careful, this is a percent, not 4, it's 4%, so 0.04. And I raised that to the number of years, Y. So 535 years. So I do a little bit of math. This becomes 224 parenthesis 1.04 raised to the 535. And we do exponents first. So I'm going to do 1.04 raised, use that little caret button, 535. Enter. Now I'm going to times that by the original amount. And it tells me 2.904. E to the 11 means times 10 to the 11th. So 2904 and 8 more zeros. So there's your $290 billion. He rounded down. They actually owe him a little bit more. And this was back in like 1996. So they owe him a lot, or him. They owe the college a lot more money. Okay. You invest $100 in 2 accounts. They each pay 10% per year. One pays simple, one pays compound. Make a table to show the growth. Let's just look at the total after 5 years. We don't need to make a table. Let's just look at what happens after 5 years. So the first simple interest, $100. Every year they earn 10%. So they earn $10 every year for 5 years. So that's $50. And if I add that to my principal amount, that's $150 that I have at the end of 5 years. Now, if I use compound interest, my amount is going to equal my principal, which was 100, parenthesis 1 plus the APR, 0.10, raised to the 5. So I'm going to put 1.1 in my calculator because 1 plus 0.1 is 1.1. I'm going to raise it to the 5th, and I'm going to times it by 100. And at the end of the end of 5 years, you would have $161.05, because that extra 1, that 1/10 of a penny, the bank's going to keep that. They're not going to give it to you. So you're $11 higher than if you had had simple interest. Now, when you're only dealing with $100, maybe that seems a little insignificant. But when you're dealing with larger amounts of money, this compound interest is going to continue to add up a lot. So let's go back to that new college king situation. Let's say the interest rate was 2%. So the amount was $224. If I'm looking at simple interest, times 0.02 gives me the 2%. So if I do 224 times 0.02, that's $4.48 a year. Well, it was 535 years. So let's multiply 535. $2,396.80 plus my 224 that I started with that they owed us. Us, like it's us, not a college in the other hemisphere of the world. $2,620.80 is what the queen would owe. Now with compound interest, my amount would be the original amount, 224, times 1 plus the interest rate, and we're going to pretend it's 2%. We're going to give the queen a break. Well, instead of 4%, we'll just charge you 2%. But my y up here is 535. So that's 224 times 1.02 quantity raised to the 535. So 1.02 raised to the 535 times 224 is going to be 8940049 and 24 cents. So we'll just tell the queen we will accept $8 million instead of $290 billion for that mistake. Look at the difference that made. 2% interest was only 8 million. 4% interest, double the interest, and you weren't just double the price. You were at 290 billion. That is significantly bigger than a 2% interest rate. Those small percents can make a really big difference. And you guys will see that someday when you go to buy a house. For example, on like a $500,000 house, the difference between a 3% interest rate and a 2.75% interest rate when everything is said and done at the end of paying it off for 30 years, that's about $18,000 the difference that you'll pay. For 0.25%, that's a pretty big difference, and that's just in 30 years. This was over 535 years. Okay, what if you're compounding more than once a year? First of all, you've struck gold, because that's hard to find someone that will do that for you. But what we do is we use a lot of the same formula, but up here, instead of just multiplying by the years, what n times y means is how many times per year. That's what the n means. How many times a year are you going to compound my interest? And then you multiply that by the years. But you have to be careful, because remember, APR is a yearly interest. So you have to divide that by the number of times per year that you get paid interest. So your percent is smaller, but it adds up to be something bigger, because you're earning interest not just once a year, but multiple times a year. So for example, you deposit $5,000 in a bank, and the APR is 3%. So I'm going to put 0.03 on top. And they compound interest monthly. So I'm going to divide that by 12, because they do it monthly. So 12 times a year. But I'm going to raise that to not just 5 years, to 12 times 5 years. So this becomes 5,000 multiplied by 1 plus 0.03 divided by 12. 0.03 divided by 12. 0.0025. That seems really small. There's no way this is going to be better. 12 times 5 is what, 60? But that's the difference right there, is this isn't only going to be compounded 5 times. Our exponent is going to be 60. So in my calculator, I'm going to do the inside of the parentheses first. 1 plus 0.0025, enter. I'm going to raise that to the 60th power, enter, times it by 5,000. And that gives me $5,808.08 with some fractional pennies left over. Now, if that had only been once a year, that would have been 5,000 times 1 plus 0.03 raised to the 5. So that one would have been 5,796.37. So you're making some more money, right? That's what? For $12 more that you made over the years. And again, that's a small interest rate with a small amount over a small period of time. The bigger those numbers get, the bigger amount of money, the better interest rate, and the longer periods of time, then this interest, because we're dealing with exponents, our account's going to grow exponentially. It's that 5 years is still kind of down here in the small growth area. Once you get to those larger amounts, that growth starts to happen exponentially. And we'll see that in some of the practice problems later. So 2 more quick concepts. APY is the annual percentage yield, which sounds a little bit confusing. All that is the actual percentage that your balance increased. So it's kind of like, we've been talking about like an absolute increase where we just found out how much my rate has gone up. But the APY is kind of your relative increase. So you find it by taking your absolute increase and you divide it by the starting principal. Or we're going to take our absolute increase and we're going to put that over our principal. Okay. And I put that formula right up here for you. The APY is your relative increase. So you deposit $1,000 into an account. So my A is going to equal 1,000 times 1 plus 0.08. Find the annual percentage yield with monthly compounding and daily compounding. Okay, so if this compounds monthly, I'm going to divide that by 12. And we're just talking about 1 year. So this is going to be raised to the 12th power. So this is monthly. Daily, A is going to equal 1,000. 1 plus 0.08 divided by 365 days in a year. Now be careful. A lot of banks use 360 days, not 365, just to make their books look nicer with zeros. It's just a power of 0 kind of an issue. So if these numbers don't match up exactly to what you see in the future on paper, that might be why. The bank might be rounding to 360. So when I plug these into the calculator, let's go ahead and put 1,000 times 1 plus 0.08 divided by 12 raised to the 12th. That's going to be $1,082.99. If I do 1,000 times 1 plus, nope, not 1 plus 0.08 divided by 365 raised to the 365. That's $1,083.27. Now, those are my absolute increases. But if I wanted to find my APY, I would take both of those, 1082.99, and I would divide that by 1,000. And I would take 108327 and divide that by 1,000. So I'm going to divide this one by 1,000. And I'll get that my rate is 1.08. So that's about 108.32%. Okay. Which really, we're just moving the decimal. So this one's going to be 108.29%, because that one's going to equal 1.082 instead of 1.083. So your APY is just the percent. So with this compounding, I didn't just go up 8%, even though that was my APR. I went up more than 8%. I went up 8.3% on both of these. Okay. So continuous compounding. One more, formula. And I mean, if compounding monthly is better and compounding daily is better than monthly, what if we compounded hourly? What if we compounded every second? What if we compounded continuously? What if we never quit compounding? That's what this formula gives us. I'm not going to show you the long drawn out proof of how to come up with this formula, because it is long, it is obnoxious. It's great, but you can see that in the textbook if you're really interested in it. What we do is a little bit different of a formula. Instead of P times 1, we're going to do P times E, which is a button on your calculator. It's kind of like pi. It's an irrational number, and it's raised to the APR times Y. So, for example, you deposit $100 for 8% for 10 years. So when I use this formula, and it's going to be compounded continuously all of the time. So I'm going to put my principal first. That's what the P stands for. Times E. E is not a variable. E is a number. It's in your calculator. I'll show you here in a minute. E raised to the APR, so my interest rate is 0.08, times my number of years, times 10. So I'm going to go ahead and plug that in. So what that looks like is 100 times. Now, E raised to a power. If I hit second and my LN button, my natural log, there's an E to an X right here. If I hit that, it gives me E with a power above it. Now, up in that box, I want to put 0.08 times 10. And then I'm going to hit enter. And in 10 years, I'm going to have $222.55. So continuous compounding is absolutely the way to go. Doesn't happen very often, but if you can pull it off, great. Your interest is going to be calculated constantly.